Good morning all. A couple of brown cardboard boxes containing Lipos. There's one and the other one is similar but slightly different. Okay, let's take a look at these, see what they are. Right, so one is a Charsoon smart battery, high discharge Lipo battery, 1500 milliamp hours, 14.8 volts, which is 4 cells. 80C, so it has a discharge rate of 80 times 1500 milliamps, which is a lot. And you can see that these smart batteries have a third wire running up to the XT60 connector. In fact, this is an XT60i connector. It says it there. It has the extra connector, that gold-plated pin on the side there, and that's what this third wire runs up to. This one is very similar. It's a Charsoon smart battery. In fact, it's identical apart from the capacity. This is a 1300 milliamp hour. I wanted two because I wanted to put one on the input of a charger and one on the output because I think it will bring up some interesting stuff. So yes, this is just a little bit less tall because of the slightly smaller capacity. So these two items have been very kindly supplied by Banggood.com. I will put links to these two items in the description below the video. They will be sales tracking links, performance tracking links, so that Banggood can see how many people are interested in this particular item. So how does a smart battery, a smart Lipo battery, differ from a regular battery, apart from this extra wire, of course? Well, let's find out. Let's connect them to, firstly, this. This is ISDT's BattGo compatible checker, Lipo checker, and it also does balancing. So this has got the XT60i connector. You can see the little extra pin down there, which replaces the little index groove on a regular battery. So let's just plug it in and see what happens. Now what I'm going to do is plug it in a little bit so that actually it's not able to see that third wire yet. And you can see that all this thing does, given just a voltage, is show that voltage, and it's 15.37 volts. Pressing these buttons doesn't do anything, but of course the situation changes completely if I push this connector in fully. So let's do that and see what happens. That third pin will make contact. We get a beep, and now we've got all sorts of information that's come in from this battery. So what this battery's got is it's got under here, presumably under this bit of foam, a chip which contains all of this information. Let's just get a little bit closer in on that. So what can we see here? Well, all sorts of stuff. Firstly, it says BattGo, so it's detected that this is a BattGo compatible battery. It says the manufacturer is Charsoon. Yes, it is Charsoon. The manufacture date is 2017, August the 28th. It's a Lipo 4 cell. Yeah, we've seen that it's a 4S battery. Now that's really useful if you plug a smart battery like this into a charger, because the charger then won't have to say, are you sure it's a 4S or a 3S or a 5S or whatever. It just knows, presumably because of data that's coming down this wire. That's my guess, that this is just a data cable, and it's presumably 5-volt data, some sort of protocol, we don't know. Okay, it's a 1500 milliamp hour battery. Yes, it is. It can take a charge at 5C. Now, it doesn't actually say that on this battery anywhere, but it's obviously in the chip. So it can take a charge at 5C. It can discharge at up to 80C. That's written on the battery. This battery, that's gone into low brightness mode. How do I get back like that? This battery has been charged, I think, or it's gone through one cycle. It's had one alarm event. I think that means it's had one charge and it's had one discharge. Now, in addition, we've got this information. 15.36 the voltage, which we saw before, 5 millivolts. That's the voltage difference between the cells. It's at a 50% state of charge. and it's at 33 degrees Celsius. There is a little temperature sensor, presumably part of the chip that's in the battery, and that's where we get that information. Now, you can see from this line here that there's another screen of information, and that is cell voltages. So it's actually telling us the voltages of all of the cells without the balance connector plugged in. 3.85 across the board. Now this is reporting it to 2 decimal places. So obviously the chip that's in the battery measuring the individual cell voltages only does it to 2 decimal places. We know, because we've seen this unit before, that this can actually measure voltage to 3 decimal places. And in fact, if I now plug in the balance lead, which is really short actually, so let's plug that in like that. Suddenly that information changes and goes to 3 decimal places of accuracy, and they are different. I think it was 3.85 across the board. This one's now saying 3.84. So of course it's measuring it in a different way. It's actually measuring it using the analog to digital converter in this checker now from the voltages that are across these wires. If I take that out again, it's now reporting the cell voltages from what it's getting digitally down this little data wire. So how useful is this BattGo thing? How important is it that you have a smart battery rather than a dumb battery? Well, probably the best way to find out is to plug this into a battery charger, and I'll actually plug one of these in as the source battery and this one in as the destination, the battery to be charged. So yeah, let's get the ISDT T8 charger out. Right, so this is the ISDT T8 charger. This is another BattGo compatible product. It's got an input XT60i connector plus a USB output, I think, for charging mobile phones. It's also, of course, got the output XT60i connector where I'll put the slightly smaller capacitor battery to be charged, and also, of course, a balanced charge lead. So first let's start by putting this 1500 milliamp hour battery into the input connector. I'll do it without, so the fan powers up. I'll do it without the XT60i, the third wire thing connected. I haven't pushed that fully in. So we've got no cell voltage information, and if I come down, we've just got information on voltage. That's all it can see from the battery. That temperature information there, let me just see if I can get that a little bit better set. Temperature information is the temperature inside this unit, and it's telling me the number of items I've charged and discharged, I think. No, total number of items. Oh, I don't know what these two mean, but anyway, no significant information on the battery unless I push this right in. And then we get that beep again, and now we've got all the information actually from the battery. Now it says here BattGo, and there's an arrow pointing down. So I think what it's telling me is that this is the information coming from the source battery. We got the manufacturer, the date. It's a 4S Lipo. Haven't got the voltage there, but that might be on another screen. Let's try that. Yeah, we've got voltage there. It also tells me that the individual cells are between 3.85 and 3.85, so it doesn't show you all the cell information, but it shows you the range. Temperature, I'm not sure whether that's coming from the battery. I don't think it is, because I think this battery was showing a higher temperature. So this is the internal unit temperature again. Cell voltages, that's not being displayed. I think that's because the input cell voltages are here. It's just given as a range. These are the cell voltages of the battery you're charging, and of course I haven't plugged anything in there yet, so let's do that now. Let's plug this in, which is that way. Now, oh, it's picked up the third wire, so let's push that fully in. Now we can see that we got information on the battery that is being charged. Let me come in a little bit closer in on that. So if I go through the screens, that's the battery that's going to be charged. That's the one on the right hand side, the 1300 milliamp hour. If I go up, This is information on the input battery. We've also got cell voltages. Now these are cell voltages of the battery to be charged, supplied by the BattGo third wire. So it's quite a lot of information here, and it's all quite confusing at the moment. And this is information on the input side battery, which is the 1500 milliamp hour. There's a page of information on that too. So back to that question, how is this smart battery technology useful? Well, if I go into the page where I'm going to charge this pack, quite a lot of stuff is already set up. So it's a Lipo 4S. It knows that from the data that came down this third wire. It's set a charge current of 3.2 amps. And I don't know whether it's done that based on the known capacity and also that information on charge rate. It may well have done. I might try that one in a second. It's going to charge. It says that the input limit, so the voltage that this pack can drop to, is 3.3 volts per cell. Now that's interesting, because without the BattGo information, this data on this wire, it would have done that as a pack voltage. In other words, it won't charge if this pack drops below 11 point something volts. Now it's saying it won't continue to draw from this source pack if any cell goes below 3.3. If I pull this partly out so that we lose the BattGo data, I think that should be enough. Yeah, and then go back into that charge screen. It's still got information on charging this pack, but it no longer says that it's going to limit the input, the source pack, on a per cell basis, because it doesn't have that information. If I push that in and go back to that charge screen, that's come back. So that's one additional feature of having a smart battery on the input, if of course this makes any sense. Charging a 1300 milliamp hour pack from a 1500 milliamp hour pack probably doesn't make much sense. It may not even have enough juice in here, given what's going to be consumed by the charger, to actually complete the charge of this. But yes, that information is provided. Right, given all this information, let's actually start a charge running, which I can do like that. Now it's saying perform the task without a balancer. Now you might think possibly that, or I thought possibly, that given that it knows the cell voltages of this pack, that it wouldn't moan about not being able to balance it. But of course, it's not going to be able to actually balance this pack, because I don't believe the microcontroller in this pack is able to actually significantly draw current from individual cells. I don't think that's a facility offered by BattGo. So if you want to balance charge where it can actually put resistors across these individual cells to keep the cells in balance, yes, you still do have to use that balance charge lead. Let's just try it without that, because it can still monitor the cell voltages, I would guess. So we'll do a start and we'll say perform task without balancer. Yes. And away it goes. It says it's charging, and we do have total pack voltage 15.4, and this is running at 3.2 amps. So and we do have the individual cell voltages, and those are being updated. Let's just reset the exposure on my camera. Those are being updated in real time. So there must be a stream of data coming over this third wire. It must be a continuous stream of data containing the cell voltage information, because we're monitoring cell voltages. Now this isn't a balanced charge. This is just a regular charge without balancing, but we can see the cell voltage information. So if we keep an eye on it, we could stop it if the cells got significantly out of balance. Now, what other information? We can see there are lots of screens here. What other information have we got while that pack is charging? We've got working info. Okay, so we've got the source battery, voltage, power in watts, range of cell voltages. The destination battery is charging at 50 watts. What else have we got? Oh, and we've just got two screens containing the BattGo information from the source battery and the destination battery. And we've got this panel telling us the destination battery type, number of cells, voltage, charge that's been transferred. and a timer there and the message charging. So quite a bit more information when you're using smart batteries than when you're not. Right, I'm now going to connect the balanced charge lead of the destination battery. Where's minus? There it is there. So that goes in like that. That gives us cell voltages. One of them's quite a long way away from the others, according to the balanced charge lead. Oh, is that settling down? I don't know. Or maybe that was an anomaly based on the capacitance on these connectors. That seems to have settled down now. But let's start the charge there. Doesn't really look any different. Might have an extra screen of information here. I don't know. Ah, right. Yes, cell impedances. So it obviously needs the balanced charge lead to work out the cell impedances, and pretty much the same information as before on the other screens. The charging working info, cell impedances, which should appear in time, and the cell voltages. Now, it's not saying balance charging, so maybe I didn't do a balance charge. Let's check that out. Task is, we've only got charge, discharge, or storage. So yeah, that must have been a balanced charge. So let's do a charge and a start. Yeah, so this must be balanced charging. So these cells should now stay pretty close to each other in terms of their voltages. So if you're an information junkie like me, and you just like lots of screens of information, then yes, you do get, we've got some cell impedances now, you do get masses of information through this smart battery technology. But the other thing is it could prevent mistakes, because this charger knows so much more about the battery you're charging, number of cells, maximum charge current, all that sort of thing. It's probably, I haven't tested this yet, but it's probably going to stop you doing stupid things like charging with the wrong number of cells selected or at too high a current. Now there is one other interesting information screen. If I press and hold the center button, it goes into the system settings, and there are 2 pages of information for BattGo related stuff. Let's just get that down. And therefore both the input battery and the output battery, and they are the same. You've got auto storage, storage voltage, current, charge voltage, exception record, which is interesting. If I go to the other one, which is the battery that's being charged, or it's not at the moment. Actually, no, that's out, wasn't it? I want the one going in. So that one. No, I want the one going out. I think I do anyway. Yes, it's got this auto storage thing. And if you look at the settings, you've got anywhere from 240 hours. Now that's 10 days. That's a long time. All the way down to, well, it's 12 hours. So from 1 day to 10 days, what does that actually mean? My guess is that you're able to tell this battery to put itself automatically to a storage voltage. Now that would imply that the little circuit board on the top here must have the ability to discharge cells. It's probably going to be at a very, very low current. If that is indeed what this is, can you tell this battery to automatically put itself in to a storage voltage after, well, 240 hours, which is 10 days? Is that what this means? Well, let's try it. Auto storage to a storage voltage of 3.8, a charge current of 1 amp, and a charge voltage of 4.2 volts. I really don't know what this stuff means, and I haven't yet seen in any of the manuals for any of this equipment any sort of detail on what this stuff is. Now I've got one other BattGo device. It's called the BG Linker. I've not taken a look at this yet, so let's open it up, and I'm hoping that there'll be more information. Let's get the actual device, which is here. Let me just reset my camera. Yeah, this is the BattGo BG Linker. It has an XT60i connector at one end, so presumably I can connect one of these batteries, and USB at the other. So I'm going to connect it to my PC, but I don't really know what software to load, and this doesn't appear to have come with any instructions, so it's kind of guesswork at the moment. There doesn't seem to be much on ISDT's website about this, so I'm going to have a little bit of a play with it, see if I can make it do something. Right, so I plugged the BG linker into my PC. It seemed to install some fairly standard USB to serial drivers, and I then went to Banggood's website, and on the listing for this device, so I'll put a link for this device as well below the video description, there was some software accessible from a Google Drive account. I've loaded that up, extracted it from a RAR file, and there's a very simple exe which you can run. That's now running on my PC, so I'll switch over to that now. So that brings up this small window. I've tried to scale it so that it's about the right aspect ratio, but this doesn't seem to provide any more information than the battery charger itself was able to see. So we've got the manufacturer, the date, there's a string of numbers here, I'm not quite sure what that is, 5C maximum charge, 80C maximum discharge, Lipo 4S, 1500 milliamp hours, 34 degrees C, that seems to have got a little bit confused, the degrees C. I'm just going to put my finger over the chip on the battery, actually, see if I can get that to raise up while I'm talking. We've got the cell voltages here, all reading 3.80. Not sure if this is live updating. Not much happening there. That's not changing. And it has this set of user preferences. At least it's calling them user preferences. Now, these were all visible, if I remember it, from the T8 battery charger. You've got this automatic storage timing. Again, it goes from 240 hours all the way down to 12 hours. It's almost implying that it will automatically set itself to a storage after that period of time and to this voltage, so 3.8 volts. This is showing it in millivolts. Oh yes, that has gone up to 35 degrees C now with my thumb over the top of the battery. The full charge voltage is 4.2. It looks like you can tweak that. You can't go up, but you can come down to 4.1, not a huge amount of range there. And the default charging current you can set. Now, it has got 1 amp in here, although when the T8 charger started charging it set itself to something like 3.6 amps. So I'm not quite sure whether the T8 kind of overrides this information. You've also got this set of exception records where it's saying abnormal cycle records. So there's some abnormal cycles going on. Well, that's not surprising because I've probably abnormally tried to charge this thing. So yes, this gives information. That's now risen to 36 degrees C, so I'll take my thumb off that now. But it doesn't seem to offer any more or any information. There's no help on this little software, this little exe file, for what this automatic storage timing thing is all about. So I might have to just try this, do a full charge on one of these batteries, set the automatic storage thing, come back 10 days later. Well, I could set that for 12 hours, I suppose. Come back a day later and see if it's put itself to the storage voltage. Yeah, interesting. The only other little snippet of information is on BattGo.org, the website of BattGo, the technology. Right at the bottom, it's got a little panel here, and it says user customized data, full voltage adjustment, storage voltage adjustment, that's the 3.8 volts, and the self-discharge time. So do these batteries self-discharge after a predefined period of time? Definitely something I'm going to have to check. If you are able to program these batteries, either using that BG linker or using a charger, to put themselves to a storage voltage after a predefined amount of time, then I can only imagine that the circuitry in here that's going to start discharging the cells is going to do it at an incredibly slow rate, because you really don't want any significant amount of heat being generated here right next to these cells. So I would imagine that it would do it over, well, many hours, I'd have thought. Now, I thought I'd just check whether this BattGo battery checker, the BG8S, has the capability to communicate with this battery. So if you press and hold the middle button, it does appear that it does. It looks like you can go to the auto storage. That's set to 240 hours. Looks like you can turn that off, or we can take that down to 12 hours. That's quite slow. So let's put that on to 12 hours. Storage voltage of 3.8. In fact, I might want to go to a storage voltage lower than that so that I know that it's actually happened. Let's go to 3.6 and just see whether it actually does put itself into storage voltage, 3.6 volts per cell, after 12 hours. I'll have to come back in a while. So currently this pack, which is the 1300 milliamp hour pack, is reading 3.88 on all the cells. So I'll come back in a day and then perhaps another day after that and see whether these cell voltages have actually fallen to my setting of 3.6 volts. So that was a first look at smart batteries. These two Charsoon BattGo compatible batteries. They don't actually have the BattGo logo on them, which is interesting. The 1300 milliamp hour and the 1500 milliamp hour. Also ISDT's BattGo BG linker, which it seems you only really need if you don't have a device such as the BG8S, the battery checker, or one of ISDT's chargers, or any other company that's making chargers compatible with BattGo. It seems that these two devices can also be used to program the user settings in these smart batteries. But for the moment, cheerio.